Alright, so this video we're going to look to find vertical asymptotes. Uh, let's look and see what it says about vertical asymptotes. It says if f of x is equal to p of x over q of x is a rational function in which p of x and q of x have no common factors. That's the important term right there. Have no common factors, and a is a zero of the denominator, q of x, then x equal a is a vertical asymptote of the graph of f. Okay, so wherever the denominator is zero, that's your vertical asymptote. So basically you set the denominator equal to zero, solve it. Okay, but you've got to make sure that the numerator and the denominator, see the p of x and q of x, you've got to make sure they have no common factors. Okay, and we'll have an example where that happens. So let's go ahead and get started. And just real quick to show you, if we have something like, say, f of x equals 1 over x minus 2, well, this graph, here's 1, here's 2. This graph here has a vertical asymptote at 2, okay? And the graph would look something like this, okay? The graph will never touch or cross that vertical asymptote. Okay, that's what we're finding, this vertical asymptote here. Okay, and some graphs have one, some have none, and some have maybe two. Okay, or three maybe. All right, but that's what a vertical asymptote is. All right, so let's look at number one. So what we're going to do is we're going to set the denominator equal to 0, and we're going to solve. Alright, so we're going to take the x squared minus 9, set it equal to 0. Okay, so we can use the square root property. We can say x squared equals 9. All I did is I added 9 to both sides. Okay, and so by the square root property, we have x is equal to plus or minus the square root of 9. So x is equal to plus or minus 3. So that tells us we have vertical asymptotes at x equal negative 3 and x equal positive 3. Okay, all right, let's take a look at the next problem. And one thing I want to show you there is we use the square root property. You could have also factored this into x minus 3, x plus 3 equals 0. Set each of these equal to 0. And so you get x equal 3 or x equal negative 3. So you get the same answer. Okay, so you could either factor it or you can use the square root property on something like that. All right, let's take a look at this one. So let's take the denominator. This is number 2. X squared plus x minus 6 equals 0. Okay, so we factor this. We have x plus 3, x minus 2. Okay, but look at this. Now see, this is the denominator factored. This factors x plus 3, x minus 2. Do you see how the numerator and the denominator have this common factor of x plus 3? What happens there is we could cancel that out and see we're just going to look at x minus 2. Okay, so we're not worried about the x plus 3 anymore because the x plus 3 is in the numerator. So we're only concerned about the x minus 2. So we're just going to take this, set it equal to 0, and solve. So I get x equal 2. And so this is my vertical asymptote. So now you might think, well, if we take the x plus 3, this factor here, set it equal to 0, we get x equal -3. Alright, so what happens there? Well, there's no vertical asymptote. What it is when the graph comes together, let's say, well, let me sketch the graph just real quick for you. Alright, so the graph, there's a vertical asymptote. Let's see, 1, 2, 3, 1, 2, 3, -1, -2, -3. So at 3, we have a vertical asymptote. So the graph, I'm starting to run off the page on it. So the graph is going to look like this, and here, now what happens here is going to look like this, but at -3, there's a hole in the graph. Okay, that's what this does when the denominator and the numerator have a common factor. That at that 0, there's going to be a hole in the graph. Okay, and then here at 3, I'm sorry, not at 3, at 2, I've been saying 3, at 2, x equal 2, this one, there's a vertical asymptote. Okay, alright, so let's look at the last one. Sorry about that mess up there. Alright, so now let's look at the last one. So we have x squared plus 16 equals 0. Now if we solve this, well, this won't factor, but we can use the square root property. So we'll move the 16 over by subtracting 16 to both sides. And so I get x is equal to plus or minus the square root of -16. So this is x equals plus or minus 4i. Okay, so what happened? This is not a real number. Not a real number. This is an imaginary number. So there's not a real number that makes the denominator 0. So for this one, there are no vertical asymptotes. Alright, so sorry about the mess up there on that one problem, but hope the video helped. Give me a like, share, and subscribe, and thanks for watching.